viewers, welcome once again to another edition of Subject Math. Before we move on, if our videos have been helpful to you, I would like you to click on the subscribe button. Thank you. Our topic today is heat energy, and here are our objectives. Today we will be considering the concept of heat energy. You'll be learning what heat energy entails, the meaning of the heat energy. Kinetic theory explanation of temperature. The third objective, effects of heat. And lastly, we will be learning about the change of states. So, starting with our first objective, which is the concept of heat energy. What is heat energy? What is heat energy all about? So heat energy is the energy transferred from the hot body to a cold body due to temperature difference. So technically, temperature is a measure of heat. What does that mean? Two bodies. This is at a temperature of let's say 50 degrees C, and this is at minus 10 degrees C. Of course, because of the temperature difference, you will agree with me that this body is a hot body and this one is a cold body. So, if this body is transferred into this body, what happens? It becomes 10 degrees, minus 10 degrees C. We have an increase in temperature. Why? Because it has been transferred from this body with an higher temperature to the body which had a lower temperature. So as a result of that, we can say that there exists heat energy between the two bodies. So heat energy is energy transfer from a hot body to a cold body as a result of temperature difference. So if the temperature does not change, if the temperature remains, then no such thing as energy transfer. But once the temperature of this one rises, then it means energy has been transferred from this body to the other body. So that means this body possesses heat energy. And one of the things I would like us to note is that heat energy is measured. It is measured in joules. It is measured in joules. And another name we term that is thermal energy. We call it thermal energy. Heat energy is also called thermal energy. Temperature is a measure of heat energy. So what is temperature exactly? Temperature is the degree of hotness or coldness of a body. Of hotness or coldness of a body. Like I cited earlier. And temperature is a scalar quantity. And the instrument used to measure temperature, what determines the temperature of a body, is called thermometer. Thermometer. So thermometer is used to measure temperature. So I want to believe this is very, very clear. Heat energy is the energy transferred from the hot body to a cold body as a result of the difference in their temperature. Temperature difference will determine which direction it will flow If a body is at let's say 80 degrees C, and you have another body whose temperature is at 50 degrees C, is this temperature that will determine the direction at which it will flow, whether it is going to flow from 80 degrees C to 50 degrees C, or from 50 degrees C to 80 degrees C. It's the temperature that will determine. Now, from here, it's so obvious that we said it flows from a body with higher temperature to that of lower. So it's obvious here that the heat will flow from 80 to 50. So it flows. How are we able to determine that? Because of the temperature. This body is at a higher temperature than this. So I want to believe that is very, very explanatory. So our second objective says kinetic theory explanation of temperature. Here we have all substances are made up of atoms, molecules, or ions. Let's take note of that. All substances are made up of atoms, molecules, or ions. These molecules are always in a constant state of motion. So we know that all substances are matter, and matter is made up of atom, molecules, or ions. So according to the kinetic theory, that these molecules, they are always moving, they are always in a state of motion. Okay, so I'm going to give us an example. Here are some molecules. So here are some molecules. I'm just going to say, let's say, molecules of a liquid. Now, when heat is applied to these molecules, this is heat. Heat is applied. Heat is applied to these molecules. They acquire kinetic energy, and they begin to move further apart. Don't forget that the kinetic theory already said that they are always in constant state of motion. These molecules, all molecules, they are always moving, but the movement varies. So they are always in constant state of motion. So what happens when it is applied? So when it is applied to these molecules, they acquire more kinetic energy, and as a result of that, they are able to move faster than they were moving initially. And as a result of that, the temperature of the body increases. So the higher the temperature, the more the quantity of heat, the higher the temperature. And conversely, when this heat is withdrawn from the body, the speed or the kinetic energy of the body of motion reduces. And as a result of that, the temperature drops. That is when the heat is being withdrawn or removed. And that's exactly what happens in our everyday life. We are boiling water, for instance. You put a cold water on your gas cooker. And what happens? Water is a liquid. So according to the kinetic theory, that the molecules of this water, they are always in a state of motion. So immediately you light your gas cooker, this molecule acquires heat. That heat flows from the gas cooker to the water molecules, and as a result of that, they acquire kinetic energy and they start moving faster, farther apart. And as a result of that also, the temperature of the water increases. Then after a while, you see that your water start boiling. And conversely, what happens when you withdraw the heat, when you put off your gas cooker? You find out that after some time, the bubbles disappear. The bubbles in your boiling water disappear. Then you find out that there's no movement after a while. Then after a few minutes, you realize that the temperature drops and eventually the water go back to being cold. So that has established the relationship between kinetic energy and temperature. So the more heat a body possesses, or the more so the greater the heat applied to a body, the greater the heat applied to a body, like I cited here, the higher the temperature. And of course, the kinetic energy increases. And that increment brings about the change in temperature. So conversely, if this statement is reversed, we have the lower the heat applied. That means the lower the heat applied, once the heat is withdrawn, then what happens? The temperature drops, the kinetic energy decreases. So I want to believe that this, our second objective, is very, very explanatory. Our third objective for today's lesson is the effects of heat. And here are some of the effects of heat on a body. So application of heat to a body can cause the following. The first one, it can bring about change of states. A good example of that is ice block. When heat is applied to ice block, it changes from solid state to liquid state, from block to water. Or when heat is applied to water, it changes to vapor. So it brings about change of state. The second one, it brings about change in temperature, of course. When you apply it to a cold body, definitely the temperature increases. When you bring out your food from the freezer, of course you don't want to eat it like that, so you microwave it or you put it on your gas cooker to warm the food. So what happens in that case is that the temperature of the food changes from being cold and becomes hot. The third application here is expansion of the body. Applying it to a body causes expansion, that's increase in length or diameter of the body. Another one is thermionic emission. Applying it to a body, especially metals, thermionic emission occurs in metals. What happens in this case? When a metallic surface is heated at a particular temperature, electrons escape from the surface of the metal. So that process is called thermionic emission. And then also, change in physical properties. When you apply it to a body, of course, physical properties changes. If I apply it to a paper, a white paper. Of course, you know that the white paper will change from being white to black, or probably it burns to become ash. So, another application is changing chemical properties of the body, change in pressure. When you apply it to your body, the pressure changes. A good example of that is your microwave. You know, when you put an airtight container in a microwave, what happens? You put airtight container in a microwave and you turn on the microwave. You find out that because of the increase in heat, the pressure also increases, and if care is not taken, that thing will just burst because of the pressure. That container will burst. So that's why it's not advisable to put a tightly fitted container inside a microwave. So I want to believe that this aspect of our lesson is well understood. So the last objective for today's lesson is change of states. Change of states. Change of state. So what happens during change of state? Note that during change of state, the temperature is constant. There is no change in temperature. So what we have here says that the temperature at which solid changes to liquid is called the melting point. So when ice block changes to liquid, that temperature is called melting point. And like I said earlier, that during change of state, the temperature is constant. So at the melting point, temperature is constant. Secondly, the temperature at which liquid changes to gas is called boiling point. That happens in the case of water. When your water is already boiling, it's changing to steam, to vapor. So at that point, the temperature remains 100 degrees C. The temperature is constant. And then lastly, the temperature at which liquid changes to solid is called freezing point. So when water is changing to ice block, water in the liquid form, when it's changing to solid, that's ice block. That temperature is called the freezing point. So very importantly, I'm going to repeat it again, that during change of state, temperature is constant. And before change of state can occur, that means heat has been applied to that body. Deposition is the change of the substance from gas to liquid. From gas to solid. The substance changes from gaseous state to solid state. While sublimation is the change of the substance from a solid state to a gaseous state without undergoing or passing through the liquid state. So the reverse of sublimation is deposition. An example of substances that undergo this, you have your iodine crystals and you have your camphor naphthalene balls. Evaporation is a change from liquid to vapor. When a liquid changes to vapor, it's called evaporation. And during evaporation, the temperature is not fixed. Evaporation occurs at any temperature, unlike boiling. Boiling takes place at 100 degrees C. A liquid changes to vapor at 100 degrees C. That is boiling. For evaporation, at any temperature which may be below 100 degrees at all temperatures. Liquid changes to vapor. That is evaporation. I want to believe this topic is well understood by every one of us. So please don't forget to subscribe to our YouTube channel, and don't forget to like our videos. Thank you.